Hi everyone, how you guys doing? Hope you're all well. So I'm trying to do my final year project, and I've asked some people for some help on understanding relays, and it's difficult, man. I really it's crazy how much I don't know. So I'm gonna start going through this Make Electronics book to try and get myself up to speed with the basics, because it's very frustrating, to be I'm in my final year of university studying electrical engineering, and I cannot figure out at all how relays work. So here I am on experiment 7, relay driven LEDs. Let me just hopefully try and grasp, how relays work. And in specific, if you really want to help me out, I don't know how to get my relay to trigger at a set voltage. So if I attach, firstly, like most people say, if you want to have a battery and you want to have a relay, and you want the relay to trigger and disconnect, like for example, an additional circuit from the battery. So in my case, a solar panel, you want the relay to disconnect that from the battery, at a certain voltage. That would be the trigger voltage. And they say that you should use, for example, a comparator. I got no idea how to use a comparator. Um, and so for that reason, I got no idea how to do it. If you know, leave a comment down below. But I'm going to try and go through this experiment 7, relay driven LEDs. Seems like a decent experiment. So I like this book. This book's a nice book. I had a guy, Jamie, in the comments. He just started an electronics course, and he asked me what book I recommend. And I went through this book in my first year, kind of skim read it, and I was like, this is amazing. So let me go and do this. Um, Thankfully, I actually bought in my first year the exact relay that he's using here, which he recommends. I bought it in the hopes that I would be able to use it, and then I never used it, and so now thankfully I can use it. So let's start with where is it? It was experiment 7, right? So experiment 6, he talks about switches, double pole, single throw. You guys should know all of that, right? So experiment 7, relay driven LEDs. You need an AC adapter, which I'm guessing is just to power the board, a DP DT double pole double throw relay, which I've got 2 of those. That's fine. 2 LEDs, a resistor 680 ohms approximate. That's fine. Push button. That's fine. Single pole, single throw. Hook up wire. That's fine. Alligator clips and utility knife. So he wants us to cut open the relay, which I probably won't do. So the next step in our explanation of switching is to use remote controlled switch. By remote control switch, I mean one to which you can send a signal to turn it on or off. This kind of switch is known as a relay because it relays an instruction from one part of a circuit to another. Often, I think that's interesting actually. Often a relay is controlled by a low voltage or small amount of current, and switches a large voltage or high current. I just want to zoom in here, but okay, so this setup can be cost effective when you start your car. Okay, blah blah blah. Similarly, when you raise the lid, blah blah blah. Before you begin this experiment, you need to upgrade your power supply. That's fine. Uh, First you'll set up the AC adapter. Interesting. Why are we going AC adapter? So before you begin this experiment, you need to upgrade your power supply. We're not going to use batteries anymore because most relays require more than 6 volts. And in any case, you should have a power supply that can give you a variety of voltages on demand by using an AC adapter. First, you'll set up the AC adapter. I assume he means AC to DC, right? He must mean, yeah. Preparing AC adapter. An AC adapter plugs into the wall. Okay, yeah, there you go. It's an AC to DC adapter. Yeah, that's fine. One of these. That's all right. Okay, so he's just telling us to cut it and then, strip it and whatnot. That's fine. All right, so the relay, the type of relay that I want you to use has little spiky legs on the bottom. It's a standardized layout. If you buy some other kind of relay, you have to figure out yourself which pins are connected. Okay. I ask you to buy 2 relays so that you can use one for investigational purposes, meaning that you can break it open and take a look inside. I might do that. Should still be usable afterwards. If not, well, you just have a spare. Okay. The easiest way to open the relay is with a box cutter or utility knife. I think I'll give that a go. Why not? I mean, I don't know. I don't want to break my relay, but he did just say it should still be usable. Okay, so here he's saying just cut it open and have a look at it. Contacts, coil gets magnetized. Okay, I don't think I will. Alright, so he's just talking about inside a relay. I'm not sure I need to understand this. I kind of do get it anyways. What really throws me off is just the symbols of everything, man. Alright, so what we've got here is when the power stops passing through the coil, the relay lets go. Compare the schematics. Okay, so it wants me to compare the schematics in 258. With switches in 238, which is different switches. The main difference is that the relay has a coil here that activates the switch. Switch is shown in its relaxed mode when no power flows through the coil. Okay, so this is open. Okay, trying to get that. The contacts are shown. All right, here's the interesting part that I really want: the coil voltage, set voltage, operating current, switching capacity, etc. That's the stuff I'm really interested in. So the contacts are shown as little triangles. When there are two poles instead of one, the coil activates both switches simultaneously. Got it? Okay, yeah, that's fine. Most relays are non-polarized. So the one that I was using actually does activate both at the same time, which is good. Okay, so relays suffer from the same limitation as switches. Their contacts will be eroded by sparking if you try to switch too much voltage. Okay? It's not worth saving a few dollars by using a relay that is rated for less current or voltage than your application requires. The relay will fail you when you need it. Okay? So, all right, here's what I'm interested in: core voltage, set voltage, operating current, switching capacity. Okay. So, the voltage that the relay is supposed to receive when you energize it. So, that's the coil voltage. I was calling it the trigger voltage. Okay. So, the voltage that the relay is supposed to receive when you energize it. All right. Set voltage, the minimum voltage that the relay needs to close its switch. Wait, what's the difference? What? So you've got core voltage, the voltage that the relay is supposed to receive when you energize it. The voltage that the relay is supposed to receive. Then the set voltage, the minimum voltage that the relay needs to close its switch. This will be a bit less than the ideal core voltage. Okay, so the set voltage is slightly less than the core voltage. Okay. Operating current. The power consumption of the coil, usually in milliamps when the relay is energized. Sometimes the power is expressed in milliwatts. So I often see that, for example, when I activate my relay, I get about 5 milliamps of current going through it. And in switching capacity, the maximum amount of current that you can switch with contacts inside the relay. Usually this is for resistive load, meaning a passive device such as a light bulb. When you use a relay to switch on a motor, the motor takes a big initial surge of current before it gets up to speed. In this case, you should use a relay rated for double the current that the motor draws when it's running. I don't think I'll have that problem. So I just need to focus on the set voltage, which is slightly less than the ideal coil voltage. Okay. So procedure. Turn the relay with its legs in the air and attach wires and LEDs as shown in figure 259 with a 680 resistor. A 1K resistor will be okay if you don't have the correct value. Also attach a push button switch. Your push button switch may look different, that's fine. When you press the push button, the relay will make the first LED go out and the second LED light up. When you release the push button, the first LED lights up and the second one goes out. Okay, so let's just, I'm all right with this circuit, but let's just make it anyways. I'll just, for the sake of the video, if you're watching this and you're not all right with this, let's just make it together. And then, I want to try and progress through the chapter and make sure I understand everything at each point. So let's do that. So it's been a whole 2 hours now. Man, this has been a headache. So I tried to do this on the breadboard and it was just impossible. So here it is. I've kind of done it like this, just copying the wiring diagram. But a problem that I've run into is that basically my relay is different to the one that the guy's using, even though I thought I bought the right one. So let's just turn on the power supply. 12 volts. And if I press the button now, it turns off. What's interesting is that like right now like this, I've got 10 milliamps of current going through it. As soon as I press this, I get 270 milliamps of current, and that's going to heat up fast. Now, the reason why this is happening is basically my relay here, where on the wiring diagram, his relay, for whatever reason, has this middle pin as the power pin, and then you've got like these two switches. So his relay is switching left, right, left, right. So for example, when you turn it on and it's unpowered, then it's on this side, and otherwise it goes on to this side. My relay is different to that. And so if you look here, you can see there that my power pin is this pin 4. Pin 4 and 13. So 1, 4, 6, 8, and then 16, 13. So the 1 and the 16 is obviously where I supply the voltage, the input. And so I need to actually be supplying the, I need to be putting the power at this 4 and 13. So I just need to switch this around, which is annoying. And I just copied the wiring diagram. So check your relay before you do this. I'm now just going to switch these 2 pins around, and then hopefully it should work. Alright, so I've switched it around. I've got 12 volts here now. Boom, works perfectly. So you can see the LEDs switched around. So power and then the 2 switches. Press the button. Hey! That is brilliant. So the way that works is, you know, quite obvious really. So you got the power supply, 12 volts coming in here, and it's just going, you know, through here. But I don't need to press the button, right? So it's going through here, into here, and then directly powering this LED, coming back through this resistor, and then coming back through ground, right? So when I press the button, then it just switches. The switch goes from this pin, the blue one, over to the green one, and then comes, you know, back out through the resistor, back through to ground. And yeah, it just does that over and over again. It's quite cool, really. So this I understand. Now I want to figure out how can I change the voltage at which this occurs. So let's see, for example, if I just turn this down from 12 volts, I'm turning my power supply down now to, so it's now at 0. Let's see at what point it turns on. 1 volt. I'm at 2 volts now. Okay, there you go. So, because basically this pin's always powered, so this is just the voltage at which, it's just the voltage at which the LED turns on. But I'm just wondering, okay, how comes it's not? Oh yeah, it wouldn't trip, would it? If I press the button. Okay, so right now that counts as tripping. All right, let me just. Okay, so I'm holding the button right now, but it's at 0 volts. Let me just go up. Okay, it went at 2.5 volts. 2.2, 2.4, yeah. Okay, so it starts conducting at 2.5. Alright, let's read how it works. So check the schematic. Okay, this is a DP-DT relay, but we're only using one pole and ignoring the other. So we're not using this right side. Why not buy SPDT? Because I want the pins to be spaced the way they are when you upgrade the circuit by transferring it onto a breadboard, which will happen very shortly. Okay. On the schematic, I have shown the switch inside the relay in its relaxed state. Schematic, switch inside the relay. Okay, so this schematic's interesting. So we've got our 12 volt DC, we've got a button which is going through to our relay. And then we've got the switch which is closed and powering one LED going through the resistor to ground. But isn't our relay button, oh, it's open? Yes, that's true actually. When you press the button, that's when it the contact, the button closes here, powers the coil, and then the switch goes and then, okay, gotcha. Okay, when you're sure you understand how the circuit works, it's time to move on. Yep, I'm okay with that circuit, so make sure you guys are okay with that schematic. Making a small modification to get the relay to switch itself on and off, as we'll do in experiment 8. Nice, okay. Alright, so we're talking about a relay oscillator. You will need an AC adapter, breadboard, DP-DT relay, LEDs, push button, alligator clips, resistor, and a capacitor. Alright, we're getting deep here now, man. I wish I would have done this stuff in my first year. I'm not even going to lie. Like, I really, really wish I would have done this in my first year. Look at the revised drawing in figure 263. Okay, here we go. And compare them with the previous ones. So the difference being, oh, okay, interesting. I was like, there's no difference, but there is. So you can see, so I need to be careful because my relay is different to the one that he's got, right? So my power pin is this first pin here, but his power pin is the middle pin. So he wants just a button. This is going to be hard, man, because we have different relays, and so I'm looking at a diagram and I'm not copying that diagram. I need to adjust the diagram to my own. Fudge, this is difficult, huh? All right, so I mean, this is experiment 8. I think I should do that for a next video, because if someone wants to follow through, yeah. All right, what I'll do is I'll end this video here and then we'll start experiment 8 from there. Yeah, let's do that, because I know people don't want to see super long videos, even though I like to talk. So yeah, thanks for watching, guys, and I'll see you in the next one. We'll do experiment 8. I'm going to start it pretty much immediately, so let's get into this. I'm excited.